Dear students, we continue our course. We talked before about the systems in the cities, about information systems that make a layer over the real systems, and we developed our skills in order to make abstractions of the real systems and to make DFD and UML diagrams to analyze the system. In the previous video and in this video, we will talk a little bit about the implementation of the design. The goal is not to make the implementation ourselves, but to understand how the design may be implemented. This will improve our skills to make the diagrams themselves. It is not important how we pronounce SQL, or otherwise, but the most important is to know that SQL was one of the most important languages related to the databases. Even if we use more and more nowadays non-relational databases, NoSQL, and other languages and database management system, but SQL is very important to understand how a database works. Instead of using examples from a database management system that we need to install in our machines, I suggested to use Google Sheets to apply our examples. Even if Google Sheets may apply a limited group of the instructions of SQL, but for us it is necessary because we can also use this experience and skills in order to analyze data later. What is SQL? What is a database? As we said before many times, a database, it is a center of data in a system, in a real system. When we started to use the computer became the main element in the information system, and by that time the concept of the database became related to the computer. For this reason, we use database management systems. What is a database management system? It is a concept related to informatics. It is the system that can manage the data, that enable us to create the data, to manipulate the data, to guarantee the integrity of the data. We will talk a little bit and we will see some examples in this video. One important family of DBMS, it is RDBMS. What is RDBMS? It is Relational Database Management System. The word relational comes from relation in mathematics. And relation in mathematics means in the application here, it is a table, the table, because it makes relation between the elements of each line, and we can understand all the relation when we see all the table. SQL is the language for RDBMS. It is the main language. It should be applied by all the RDBMS. So SQL now, it is not a language for one application. It is a language for all these type of applications. And for this reason, we will take some instructions from SQL. SQL, it is standard query language. With SQL, we will see that we precise what we need, not how the computer will realize what we need. For example, SQL contains a create instruction, insert instruction, select from instructions, grant, revoke, writes, from or to instructions. We see that these instructions are easy. If we understand English, it is easy to understand these words. We have in SQL perhaps 20, 30 words from English, and we can understand them immediately. When we use the command create table in SQL, we don't know how the RDBMS will create this table, but we will see the result. The table will be created. It is the same thing when we ask the RDBMS to insert a line in the table, or to remove a line, or to update a column in the line. SQL may be executed widely in a lot of platforms. We have MySQL, Access, SQL Server, SQLite, etc. We have a lot of. Also, Excel and the last versions of Excel allows us to use a huge commands of SQL online also. Google data sheets, we will see that we can execute a group of SQL instructions, and always in the famous programs there is a database inside. When we talk about GIS, we talk about BIM, there is a database, and we can use some extensions, and most of time we can use SQL in these platforms directly or indirectly. We can install sometimes some extensions in order to use SQL in these applications. GIS applications are very famous these days. GIS, it is Geographical Information Systems. But what is GIS? If we see deeply, what is the base, what is the node, what is the heart of this GIS, we will see that it is a database that may register the latitude, the longitude, and the altitude. So we precise the localization of a point over all the globe. And if we precise the localization, we can calculate, for example, the distance between 2 points. We can know if one point is near or far from another point. We can make a meaningful relationship between these points basing on the geographical localization. So it is very important to understand what a database means, because all the application that we use in a GIS, it is related to the database. From our connected home, every time we take examples, we know that we have sensors, and the sensors, we put them in modules most of the time, and we put the modules on the walls. We say that we have different types of sensors. Some sensors we can put them immediately in the wall, and we analyze the behavior of a room or of an apartment. So we have a sensor that is related to a home. We have different type of sensors. Some sensors may be connected directly in a room, in an apartment, for example, and it can sense values. And usually when we put the sensor, it has a precise localization in a room, in an apartment. So we may have different types of tables. One table for we extract our examples most of the time from our project Connected Home. We know that in this project we put sensors in apartments or in buildings, and we fix them. We fix some of them in the rooms to understand the behavior of the rooms and the apartment and the neighborhood, etc. So one useful table in our project may have this form. We have a table that is related with some sensors, we put it date, time, value, and sensor number. So each time when we receive a value from our sensor, we register it immediately in this table. So we have, for example, here, we have in the first line a value that is 21.70. It may be the temperature at this date, where that comes from this sensor, the sensor number 1. And after that, we have another value that comes from sensor 2. It is almost the same. So we can imagine that these sensors are in 2 rooms in the same apartment. This table is not enough to represent all the project. We have a lot of tables. Another useful table may be the table that match between the sensors and the localizations of these sensors. For example, here we have sensor number 1 or 2, and what is the type? The first, it is temperature. The second, for example, it is humidity. Where we put, if we follow the first line, sensor number 1, it is temperature. We fixed it in room number 3. What is the height? Because usually when we fix sensors, we try to put them at the height of the human in order to understand the comfortable parameters in the apartment. So most of the time we choose 150 centimeters as a reference. It may be for local conditions higher or lower, or perhaps if we want to install the sensor for other purposes, we can change this height. For example, if we put the sensor in an elementary school, usually we try to put the sensors at the height of the children. What are the suitable SQL command that is good? How can we see this table, the table of the values of the sensor? With SQL, we can select star from the name of the table. We have a similar instruction in Google data sheets. So we make a query. In a query, at first we put the name of the table. After that, we put /* semicolon 1. We will try to execute this instruction before continuing our course. We will try to execute this instruction before continuing our course. So we put, as you see to the left, we put the columns of the table. So we will say query the name of the table. It is sensor values semicolon select star So we will try, we enter enter, and usually we will have the table. It is a very huge table, so we saw all the elements of the table. Perhaps you will ask me why, if we see it here, why we print it again. Usually we don't see the first part. We saw how this instruction is executed. We should, to make the relationship between the diagrams that we developed and these tables, we can mention that these diagrams are similar to class diagram. If you remember, we have the name of the class with the attributes. We have the first table and we have the second table. If you see here, it is very important to make the relationship between the two tables. In the first table, sensor values, we have date time value sensor number. In the other table, we have sensor number, type, room number, height. What makes the relation between these two tables? It is sensor number. This is very important. So we should have one parameter from one table, from the first table, to connect the other. If we don't have such column, the two tables are isolated. So even if we don't have exactly the same name, but we should understand this relation. If we don't mention this relationship somewhere, that means the two tables are isolated. So from the table sensor, from the class sensor, from the entity sensor, there is a relationship with the other table. In database, we call the sensor number in the sensor table, we call it the primary key. We explained that before. And we call it in the second table a foreign key. This concept is very important to correlate all the tables of the database. When we see the database, we see tables with relationships between these tables, and how we optimize this design. It is and the most important question when we design the database is to understand how we optimize the structure, how we make the tables, what we should put in each table, and what are the elements that make the relationships between the tables. This allows us to reduce the size and to guarantee the integrity of the database. The select statement, it is the most important instruction in SQL. We can see that we understand almost all the words. Select, it is the instruction. Distinct or all. We can decide to see all the lines or to remove the repeated lines of the output. We have star, that means everything. Pipe, colon exclamation, we should precise which columns we want to see. As new name, we can change these names when we will see the output. From table, we should precise the name of the table. This is the most important, from which we will extract the data. They may be 2 or 3 tables, we will see that later. Where condition, it is a type of filter we will apply on each line if we want to put it in the output. Group by, so we can group the lines based on one attribute. Having conditions, we can apply a condition over the groups that we formed. Ordered by, so we can also order the results using one column or more column, because we see column list. We will see all these, we will see the application of these instructions in the next slides. For example, I have sensor values, I have XUL, select datetime, value from sensor values where values is more than 21. What does it mean? That means we will choose only 2 columns from the table, and we'll choose only the values that are more than 21. It is a type of filter. The corresponding Google datasheet query, sensor value is the name of the table, select A or B. So here we should know where we put our table in the sheet, and we should choose the name of the column of the sheet, not the name of the table. Where also, instead of choosing the name of the column of the table, we should the corresponding column in the sheet B are more than 21. We will see that in the data sheet. So you see here that date time, it is in the column A. We see that value, it is in the column B, and sensor number, it is in the column C. If we want to apply this command, so we will come here and we will choose the instruction. We will say that we have this instruction. We will choose A and B, where B is more than 21, and we will execute. So here is the results. We see here in the result, you can see here that all these values, we have only two columns as we precised. We precise that we want that the output comes from the column A and B, as you see. You see here. Here we precise that we want to filter the columns A and B, so we want that the output comes mainly from A and B. We didn't mention column C, and the condition is B more than 21. For this reason, you will see that all these values are more than 21. Average, we can calculate the mean. It is very easy. We can precise average value from sensors. The corresponding command on Google datasheets is query sensor values select average B. So we only pay attention to the name of the column. We will apply it. Here I would say AVG B only. You see here, with one instruction we could calculate the mean. The mean is 21.06, etc. We can use also aggregates, max, mean as average. The application is the same. So here we can put many values together. We will search average B, max B, min B at the same time. We will apply that. So you see the query, it is almost the same. We will add max, min, and we will apply it. It does not work. We will search Y. We should precise max. What? Its max value. It is in the column B. We have, if you can see immediately, we calculated the mean and the max value and the minimum value. So we have that the minimum value it is 17.1, the maximum value it is 27.5, because it is related to the temperature between almost 6 or 4 months for a group of sensors. Count, it is very important. It is to know how many lines we have related to some filter. So if you say, if you want in SQL to know how many values we have, we can use the same thing in datasheet, Google datasheet. We write only count. So here we will write count B. So we have, you see it is almost in a part of the second, and we have more than 66,000 lines in our data sheet. We can use the aggregate functions with the condition also. Here, for example, we can know how many lines are related to the sensor number 1. It is the same. We should pay attention to replace the name of the columns. Where C, it is the number, sensor number, is more than or equal to 1. So we see that we have almost 24,000 lines related to the sensor number 1. The number of lines, if you remember, it was almost 66,000, and we have almost 24,000 related to the sensor number 1. We have group by, it is very important, because we can group many lines from some columns related to a condition in other columns. For example, we can separate the values that come from different sensors. For example, count value comma sensor number. What does it mean? In our data, we have 3 sensors. Number 1, number 2, number 17. These instructions means we will count how many value from the second column is related to sensor 1, how many values are related to sensor 2, how many values are related to sensor 17. So it is very useful to analyze the data. And the group, how we precise that? Because we said that we will group these values regarding the number of the sensor. It is almost the same thing in datasheet. Count B. So it is count B, comma C, group by C. We'll have the result. So you see we have the sensor number 1, number 2, number 17. For sensor number 1, we have 24,589. For sensor number 2, we have 21,115. For sensor number 17, we have 21,000. 1000 value 115 also. Take some time, try to answer to the question in the bottom of the slide. What is the meaning of query sensor values select max B group by C? Try to reanalyze the first question and take your time to answer to the second. It is easy. That means we will organize the output regarding the parameter that we chose. We choose sensor N. That means that the results will be organized by the number 1, number 2, number 17, or we can change also the order. What is important here that we can also choose many columns. So we can choose that the order should be by the column 1, then by column 2, then by column 3. So we will devise all the values in groups. After that, we will organize each group separately using the second parameter. For example, if you want to organize our data by the second column, or by the third, it depends what we want. So we can say we want everything order by C. So it takes some time because we have, as you saw, we have 66,000 value, and it is a type of organizations of all these values. If you see, we see here that we start by always by sensor 1, 1, 1, 1, 1 to the in the third column. After that, we will find sensor 2. After that, sensor 17. Okay. If we go to the bottom, we will have 17. We will ask, we will change, we will say that we will see the values so we see now that we arranged the table by the middle value here, by the temperature, so we know when the coldest days were. So it was in March during this registration, and we can see that even we registered low temperatures in May. So we continue. One of the most important aspects in SQL, it is the ability to correlate, to make relationships between tables. Unfortunately, this is not the case. Unfortunately, with the Google datasheet, we cannot make the same thing because the logic behind the datasheets is different from the logic behind SQL. But it is important also to give you an example from SQL, because it is important to understand how we correlate the tables. What is important for the inhabitant is not the number of the sensor, even for analyzer. What is important for the analyzer is the house. What is the temperature of the house? What is the temperature of the apartment? What is the temperature in such room? So the number of the sensor is not important. For the inhabitant or for the researcher, it is meaningless. because what is important for us, it is the room, the conditions in which the human live. How we can do that? SQL allows us to make relation between two tables, so we can join 2 or 3 or 4 tables. Most of time we join 2 or 3 tables. It is very important. As I said before, to join 2 tables, we should know the shared column between these 2 tables. In the proposed example, we have 2 tables, sensors and sensor values. In the sensors values, we have the date time, we have the value, and we have the number of the sensor. In sensors, we have the number of the sensor, we have the type, if it is temperature or humidity, etc. And we have also the number of the room in which we put the sensor, and we have also the height in which we fixed the sensor. How we can know the temperature in a specific room? How can we know the temperature in a specific room? We should join the 2 tables. How can we do that? We say select, but because we have 2 tables, we should precise the column with the name of the table. We say select sensors values. From the table sensor values, I will choose the date and the time, the value also, from the first table to the left. And from the table sensors to the right, I will choose the type of the sensor. And perhaps I will choose the room. I can choose also the number of the room. From what? From sensors values, it is the first table. The second table, what is it? Join, inner join, sensors. The database will create a huge table to cross these 2 tables together on. So what is the relationship between these tables? What is the parameter that allows me to combine these 2 tables? It is sensor values, sensor number in the left table should be equal to sensors sensor number also to the right. That means the database will create a new table, huge table. Database management system will extend the first table with the values of the second table. After that, from this table, it will give the results, the output. So the database management system will take the first table. After that, it will extend it with the value from the second table. Then it will calculate the results to give it to us. For this reason, we can add here some conditions to say, for example, where the number of the room is equal to 1 or 2 or 3, to precise that we want the sensors from this room. And we can make another conditions also to say that we want the rooms, the number of the room, and we want the type of the sensor to be temperature or humidity, for example, or another type of sensors. So, to explain that, we had 2 tables. When we used the join, what happened? We complete the lines of sensor values with the columns of the first table using the connection. The connection is sensor number. So the database management system will look to the sensor number 1, for example, on the first line of the table. It will search the column that is related to this table, to this number from the second table, from the sensor tables, and it will add it to complete it. This is a very complex operation. The complexity is very important for this. It is as the subject of a research for people who work in mathematics. But in this course, it is not our domain, and we should be able only to know and to use this, because everybody, as you know, talk today about the huge databases, about the big data, about data analysis, etc. And these type of instructions, they are very easy and very useful in the next videos, I will explain how can we convert our class diagrams and other diagrams into a database.